So now I'm talking about the sign convention. So what is sign convention? Sign convention. Okay. So in general, object should be kept. Object should be kept at the left side, at the left side of mirror. Object should be kept at the left side of mirror. So we can say that if object is kept at this side, if object is kept at this side, and we know very well in coordinate system, if there are two axes, x and y axis. So this point is known as origin. And if you move towards right direction from origin, so that is positive x-axis, and this is negative x-axis. Upward direction, that is positive y-axis, and in downward direction, that is negative y-axis. Okay, are you getting me or not?
Yes, sir.
Okay, now. So consider that one object AB is kept at the left side of mirror. In this diagram, you can see that an object AB is kept at the left side of this concave mirror. So we can say that U is negative. We can say that U is negative for this case. U will be negative because the object is kept at the left side of the mirror. All the distances are in left direction, so that will be negative. Okay.
Yes, sir.
So I think this is all clear now. Now we have understand that U is negative. U will be negative. Focal length of concave mirror is negative. Focal length of concave mirror is negative for concave mirror. Okay. And focal length for convex mirror is positive. Convex mirror is positive. Now what about V? What about V? V is what? The distance of image. And as we know that all the distances are taken from origin. All the distances are taken from origin. Okay. If anybody says that image is formed at a distance of 10 centimeter. So it is understood that the distance 10 centimeters are taken from the origin. Okay. Is it okay or not?
Yes, sir.
Okay. So now we'll discuss. We have discussed mirror formula. This is our mirror formula. 1 upon f is equal to 1 upon v plus 1 upon u. This is our mirror formula. Okay. And now we'll move further. Linear magnification. So what is linear magnification? Actually, linear magnification is nothing but the ratio of, it is a ratio of size of image, ratio of size of image to the size of object. To the size of object. Okay. And it is denoted by small m. It is denoted by small m. Okay. So this is the definition. This is the definition for linear magnification. The ratio of size of image to the size of object. Books में आपको ऐसा भी लिख के आ सकता है height of image. Okay. Height और size एक ही बात होगी ना. Height हो या उसका size हो एक ही बात है. So the ratio of height of image to the height of object size may be height here. Okay. There is no problem. If I am using size, I am using height, there is no problem. So the formula for linear magnification M will be size of image divided by size of object. Size of image divided by size of object, or I can say that height of image divided by height of object. Is it okay? Height of image divided by height of object. Both are same things. There is no difference between size and height. Okay. This is height and this is also size. Both are same. So it is denoted by HI and the height of object is denoted by HO. I means image. O means object. So the formula will be M is equal to HI divided by HO. This is the formula for linear magnification. M is equal to HI upon HO. Any kind of problem? If you are facing, then tell me.
No, sir.
Okay. So this is the formula for linear magnification. Okay. And there is one more formula. M is equal to minus V upon U. M is equal to minus V upon U. Now, what is V? Can you tell me about V? What is V?
Distance from the image.
Distance of the image. Distance of the image. From where it is taken? From which point it is taken?
From P.
From P. From the pole of mirror, because pole of mirror is treated as origin and all the distances are taken from origin. Okay. Now, what about U? What about U?
Distance of the object.
Distance of the object. And from where, which point this is taken?
P.
P. Why? What is the reason? Because अभी तो बताया था मैंने. भूल गए? All the distances are taken from origin and pole
Yes.
is treated as origin. So remember that U and V are the distances of object and image respectively from the pole of mirror. From the pole of mirror. Any problem?
No, sir.
Okay. So in this case, we can say that M is equal to minus V upon U. V is the distance of image. V is the distance of image. And U is the distance of object. And both distances are taken from the pole of mirror because pole is treated as origin. मैं ये देखो कई बार बोल रहा हूँ, रिपीट कर रहा हूँ इस चीज को जिससे कि याद रहे तुमको ना. तो याद रखना इसको, remember that. Now we are finding some other formula. So listen. Okay. As we know that 1 upon F is equal to 1 upon V plus 1 upon U. What is this? Which formula is this?
Mirror formula.
This is known as mirror formula. Okay. If we multiply the equation by U, both sides, so it can be written as a U upon F is equal to u upon v plus u upon u. Is it okay or not? We
Yes, sir.
multiplied that equation by u, both sides. So it will be u upon f, u upon v, u upon u. Is it okay? U and u is
Yes.
cancel out one time. So we can say that it will be u upon f is equal to. Now what about u upon v? U upon v in terms of m. U upon v in terms of m. Can you say about this all? As we know that m is equal to minus v upon u.
Yes,
M should
sir.
be written as m upon 1. Okay.
Yes, sir.
So the reciprocal of this equation will be 1 upon m is equal to minus u upon v. अरे अब माइनस को इधर लगाओ या फिर इधर लगाओ, एक ही बात है, इससे कोई फर्क नहीं पड़ता ना. माइनस तो दोनों साइड
Yes.
में से कहीं हो सकता है. So u minus u upon v is written as 1 by m. And if you remove the minus from this side and put it at this side, so there is no problem, I think. Both
Yes, sir.
equations are same, na? Both equations are same. So at the place of u upon v, we can write minus 1 upon m. We can write minus 1 upon m. At this place, we can write minus 1 upon m. And this one is same, plus 1. Is it okay or not?
Yes, sir.
Okay. So this equation is also written as 1 by m is equal to 1 minus u upon f. Okay. So 1 upon m is equal to 1 minus u upon f. So take LCM here. So the LCM will be f. So this equation is written as f minus u. This I am taking simply LCM, nothing else. Okay. Now m is equal to f upon f minus u. This is another formula and very important formula. Okay. So now we have three formula for linear magnification at this time. First is m equal to hi upon ho. Second is minus v upon u. And third is f upon f minus u. If you are facing any problem in these three formulas, you may ask.
No, sir.
All is clear?
Sir, in the mirror formula, shouldn't we be minor in negative?
No. एक्चुअली क्या होता है कि साइन कन्वेंशन का यूज अभी हम लोग करेंगे. ठीक है. It depends on the nature of the image. Actually, there are two types of image. Okay, wait. I am explaining in detail. Wait a minute. Okay. Actually, I was adding the slides. Okay. So there are two types of images. There are two types of images. Okay. First is real image, and second is virtual image. First is real image and second is virtual image. Okay. If the image is real, it should be inverted. If the image is real, it should be inverted. Okay. And if the image is virtual, it should be erect. And what is the meaning of inverted? What is the meaning of erect? Do you know about this? Consider that this
Yes,
is a principal axis. This, do you know?
yes, sir.
Okay. So consider that this is a principal axis and this is a concave mirror. Okay. I'm taking here a case of concave mirror only. Okay. So this is a concave mirror. If object is placed something like this, AB, at the upper side of the principal axis, means it's facing at the upper direction, and its image is sorry, its image is in downward direction. So it is called inverted. It is called inverted. मीन्स ऑब्जेक्ट रखा हो ऐसे ही, ऑब्जेक्ट ऐसे रखा है और इसकी इमेज नीचे ऐसे बन रही है. ओके, सो दिस इज नोन एज इन्वर्टेड. उल्टी इमेज बनेगी. एंड व्हाट अबाउट इरेक्ट? ऑब्जेक्ट ऐसे रखा हुआ है और उसकी इमेज भी ऊपर ही बन रही है. सो इट इज नोन एज इरेक्ट इमेज. इज इट ओके और नॉट?
Yes, sir.
Now what about real image? What about real image? So look at this mirror. This side is well polished. This side is well polished. So no light can pass through this medium. मतलब जैसे आपके पास अगर एक प्लेन मिरर है, आप उस पे से कोई टॉर्च लगा दो, मान लो यहाँ से कोई रोशनी लगा दो, लाइट लगा दो, तो लाइट उस साइड जाती है क्या?
No, sir.
नहीं जाती ना. क्यों नहीं जाती? क्योंकि दिस साइड इज वेल पॉलिश्ड. दिस साइड इज वेल पॉलिश्ड. ओके. अगर तब भी लाइट इस डायरेक्शन में आ रही है, अगर तब भी आ रही है, तो समझ जाना कि वो वर्चुअल है, क्योंकि रियल में तो हो नहीं सकता ऐसा. इट इज नॉट पॉसिबल इन रियल बिकॉज दिस साइड इज वेल पॉलिश्ड. ओके. सो बाय दिस ऑल वी कैन अंडरस्टैंड that u is always negative in general. U is always negative because object should be kept at the left side of mirror. Object should be kept at the left side of mirror, so u will be negative for all. So remember this point, u is always negative. Okay.
Yes, sir.
Okay, now what about v? What about v? V is distance of image. And we are having two types of image. First is real image and second is virtual image. We are having two types of image in this case. First is real image and second one is virtual image. For real image, if we talk about real image, so we can say that V will be negative. V will be negative. V negative क्यों होगा? क्योंकि कोई भी लाइट रियल में तो राइट साइड नहीं जा सकती ना. कोई भी लाइट रियल में तो उस साइड नहीं जा सकती क्योंकि ये वाली सरफेस जो है वो पॉलिश्ड है. दिस सरफेस इज वेल पॉलिश्ड, सो नो लाइट विल पास थ्रू दिस मीडियम. ओके. एंड एज वी नो दैट दिस इज पोल, दिस इज आवर पोल, एंड पोल इज ट्रीटेड एज origin. Okay. If this is origin, so this side will be positive and this side will be negative. If this is for origin, so this side will be negative and this side will be positive. Are you getting me or not?
Yes, sir.
Okay, okay. So I am saying that if a pole is treated as origin, so this side will be negative and this side will be positive. Okay, is it okay? Now, yeah. So light is not going in this medium in real. It is bouncing back in the same medium. It is changing the path. Light is changing the path without change in medium. So we can say that V will be negative for real image. इसकी जो ये जो ऑब्जेक्ट रखी हुई है, इसकी इमेज यहीं तो बनेगी ना, इसी साइड में तो बन जाएगी, लेफ्ट साइड में ही, लेफ्ट साइड में ही बन जाएगी इमेज. अगर इमेज लेफ्ट साइड में ही बन रही है तो वो V कैसा हो गया, उसके लिए नेगेटिव हो जाएगा V. बताओ इतना क्लियर हुआ कि नहीं हुआ ये? Is it clear or not? Why V is negative? V is negative. So why is it negative? You got it or not?
Yes, sir.
You got it? Confirm.
So can you explain once again?
Okay. Listen. We are talking about real image. Okay. We are talking about real image. Light is incidenting on the mirror from the left side. So U will be negative. All the distances of left side will negative. All the distances of right side will be positive. Okay. Because pole is treated as origin. Consider that this is pole. So this side should be positive na. And this side should be negative. Is it okay or not? This side should be
Yes.
positive and this side should be negative. And object is kept at this side. Object is kept at this side. This is object. Object is kept at this side. Okay. And if
Yes, sir.
its image is forming in the same side, consider that this is image. This is image. Okay. This is image. So V will be negative because V is the distance of image. No? V is the distance of image. V is the distance of image. So V will be negative. Now, अब बताइए आप कि ये चीज क्लियर हुई कि नहीं? Is it clear or not?
Yes, sir.
Why V is negative? Tell me the answer. Why V is negative?
Because if the mirror is a, a virtual mirror, no, a real mirror, then no. If the object is always on the left side of the image, and anything that is on the left side of the mirror is always negative. So if the image formed of the object is also on the left side, then it will be negative.
Okay, V will be negative. Okay, we can say it that if the image is forming of the object at the side of object, because object is kept at the left side. Object is kept at the left side of mirror. Consider that this is a mirror. This is a mirror. This surface is well polished. This surface is well polished. Okay. So this is an object. This is an object. Okay. So if this is an object and its image is forming at this side, consider that this is image. So this image is real or not? This image is
Uh,
real or not? It is also real. Okay. So why is it real? Because V is negative for this. So we can say that if we talk about real image, so V will be negative. V will be negative for real image. Okay. Now I'm talking about the virtual image. So what about virtual image? I'm changing the slide. Okay. Virtual image. So consider that this is a concave mirror. Okay. And this line is known as principal axis, as we know that very well. This line is known as principal axis, and this mirror, concave mirror, concave mirror. As we know that always object should be kept at the left side of mirror. So object is here at this point. So this is an object AB. This is an object. Okay. And if the image of this object is forming at this side, if the image of this object is forming at this side, consider that this is a image. This is an image. So this image will be virtual. This image will be virtual. Why is it virtual? Why is this virtual?
Because this is on the other side of the mirror.
Yes, this is on the other side of mirror. And which side? This side is well polished.
Yes.
The light ray never go to this side. In real case, these are going in this side or right side of the mirror virtually. Is it okay? So this image is known as virtual image. मतलब मेरा ये है कि लाइट जो भी है वो लाइट यहाँ पे पॉलिश है तो उस साइड में जा ही नहीं पा रही ना, वो तो यहाँ से इधर से आके वो तो यहाँ पे वापस लौट जा रही है, रिफ्लेक्शन हो रहा है यहाँ से. Okay, so we can say that this image is known as virtual image. And if the image is virtual, it is also an erect image. If the image is virtual, it is also an erect image. I think, is it clear? So we will be positive for this case. Yani, for virtual case, for virtual image, we will be positive. And for real image, if we talk about real image, we will be negative. Now this is clear or not?
Yes, sir.
So remember these two things, okay? V is positive for what? We are having two types of image. Listen one more time. We are having two types of image. First is real image. Second is virtual image. Okay. If we are talking about real image, then real image will form at the side of object, means left side of object, because this is a real image. Okay. And if we are talking about the virtual image, so the virtual image will form at the other side of object, at the other side of object, or we can say the right side from the pole. Virtual image always form at the right side of the pole. Virtual image is always formed at the right side of the pole. I'm writing this statement. Virtual image always form. Virtual image always formed at the right side, of pole. Is it okay or not?
Yes, sir.
And if we talk about real image, consider that this is the first point and this is the second point. If we talk about the real image, so real image always form at the left side of pole. इतना क्लियर हुआ आपको कि नहीं हुआ, ये बताओ.
Yes, sir. Sir, so if there is a real mirror, both V and U both will be negative.
Mirror is always real. Mirror should be real ना. Mirror तो real ही होगा. अरे mirror is an object. We can see it. Mirror is an object. We can see it. Na? And if we are seeing anything, that is real. You are seeing me. So I am real. I am not a virtual. But this medium is virtual. by which you are seeing me. But I am real. I am not a robot. Okay. So
Yes.
mirror is always real, but the image should be real or virtual. Image may be real or virtual. Okay. So remember these 2 points. Virtual image always form at the right side, and real image always form at the left side. So these 2 points is more important for you. Okay. So we were talking about, I think, yeah, linear magnification. So this topic is linear magnification, and we are discussing about the formula. So first formula is this, second formula is this, third formula is this. Okay. Now we are moving for the next formula. We are moving for the next formula. Okay. So as we know that this is mirror formula. 1 upon f is equal to 1 upon v plus 1 upon u. Okay. Now multiply this equation by v, both sides. Multiply this equation by v, both sides. So this will be v upon f is equal to v upon v plus v upon u. Okay. Is it okay or not?
Yes, sir.
And v are cancel out one times. And as I told you before, that m is equal to minus v upon u. M is equal to minus v upon u. That is called linear magnification. So we can write this equation such as minus m is equal to v upon u. Is there any problem?
No, sir.
माइनस साइन तो कहीं भी लगा सकते हो, राइट साइड लगा दो या लेफ्ट साइड लगा दो, उससे क्या फर्क पड़ता है? So put the value of v upon u here. So this should be v upon f is equal to, this will be 1, and minus v upon u is what? Minus m. So this is minus m. So this will be m is equal to 1 minus v upon f. 1 minus v upon f. So take LCM here. So m is equal to f minus v upon f. So this is the formula. This is another formula for linear magnification. M is equal to f minus v upon f. So now we are having 4 formula for linear magnification. First is m is equal to hi upon ho. Okay. Second is m is equal to minus v upon u. Third is this formula, that is m is equal to f upon f plus u. And fourth is this formula, f minus v upon f. F minus v upon f. This is fourth formula. So remember these all formula. Questions करेंगे इस पे अपन. ठीक है. तो जो भी आपको आज डाउट है वो मेरे से अभी क्लियर कर लो, फिर आगे चलते हैं.
Sir, no doubt.
नो डाउट. ओके.
Yes.
तो आपको ये कुछ नोट वगैरह करना है कि मतलब क्या, मतलब नोट्स में ऐसे ही ये इनका पीडीएफ बना के आपको दे दूंगा?
Yes, sir. सर मैं स्क्रीनशॉट लेते रहता हूँ.
हाँ तो ठीक है. So Okay, one more thing. Wait a minute. One more thing I want to discuss with you. Slide फिर से खत्म हो गई क्या? Okay, I am adding the slides. Okay. So one more thing I want to discuss, that we are having two types of images, real image and virtual image. Real image and virtual image. For real image, U is always negative, and for virtual image, U is always negative. Means we can say that U is always negative for real image as well as virtual image. U is always negative. Now what about V? बताइए, रियल इमेज के लिए V पॉजिटिव होगा कि नेगेटिव होगा? क्या?
Negative.
Negative. Very good. And for virtual image, V will be
Positive.
positive. Now I'm talking about M. M is positive or negative for real image. M is positive or negative for virtual image. So M, the formula of M is minus V upon U. As I told you before that M is equal to minus V upon U. Okay. So we can say that M is equal to, this minus is God gifted. This minus is God gifted. Now what about V? V is negative. V is negative for real image. And U is always negative. So both negative sign are cancelled out. But this negative sign will remain same. So M will be negative. M will be negative. Because this negative sign will not remove. Is it okay or not?
Yes, sir.
Okay, now if we talk about in this case, means in virtual case, virtual image, so M is equal to minus V upon U. So we can say that this minus will remain same. This minus will remain same. What about V? V is positive. V is positive for virtual image. So plus V divided by U is negative for virtual image. So minus U. Now we are seeing in this equation that minus and minus are cancelled out. So M will be positive. Is it clear or not?
Yes, sir.
So remember these 2 points also, that M is negative for real image. And M is M is positive for virtual image. Okay. So now
Yes.
we are having two types of images. First is real image. So for real image, U is negative, V is negative, and M is also negative. All these three quantities are negative for real image. Okay. And if we are talking about the virtual image, so for virtual image, U is always negative, V is positive, and M is positive. This is for virtual image. Okay. ये बहुत ही इंपॉर्टेंट चीज मैंने बताई है, आप इससे क्वेश्चंस हो जाएंगे बहुत सारे, समझ रहे हो ना? ये स्टार मार्क कर रहा हूं मैं. इस पे कई सारे क्वेश्चंस होते हैं. There are too many questions and some we'll practice some questions further. So if you have any doubt, so you may ask.
No, sir.
No doubt.
No, sir.
Okay, तो अब हमको क्या था कि कुछ क्वेश्चंस करने थे. आज मैंने जितना सोचा था हालांकि उतना तो मैंने नहीं करा पाया. अभी हमको यहाँ पे ये क्वेश्चंस स्टार्ट करने थे, है ना. ये अभी हमारे इसमें क्वेश्चंस रह गए थे. ये क्वेश्चंस अपन अब नेक्स्ट क्लास में करेंगे. नेक्स्ट क्लास अपनी कब है? कल तो नहीं है? कल है क्या अपनी क्लास? कल नहीं है ना?
Sir, I don't know. पापा को पता होगा.
हेलो, आर यू गेटिंग मी और नॉट?
Yes, sir.
मैं ये पूछ रहा हूँ कल अपनी क्लास है क्या?
Sir, पापा को पता होगा.
अच्छा अच्छा, कल नहीं है मेरे ख्याल से क्लास.